talking about what's called the common logarithm. All right, the common logarithm. And the common logarithm is always in what base? What base are we going to work in? Base 10. So whenever I write log without a base, you're assuming that it's going to be a base 10. Now, we did this problem yesterday, but we did it by guessing and checking, right? Guess and check, guess and check. And I believe Bailey found it to be 3.0885, and that got us really close to 47.9. Okay? Now, she got it right, but it took her quite a few times in the calculator before she was able to find the answer to what? 4 decimal places. So today what we're going to do on this video is show you how to get to this answer without having to guess and check. So, step number 1. You can put this in your journal. Step number 1. You're going to apply what's called the common log to both sides. So apply the common log to both sides. So right now, here's what it's going to look like. I'm going to write log of 3.5 equals log of 47.9. Now, one thing you don't have to do when you apply the common log, you don't have to write a 10 here, and you don't have to write a 10 here, because we already know that it's base 10. Now, up here we have the value of x. And I'm going to highlight this in orange, because that's the second step every single time, is you're going to use the power property to bring down the x. All right? So we're going to take the power property, we're going to bring down the x right in front of the log. So this is what it's going to look like now. You're going to have a big ol' x right in front of your logarithm. And you're going to write 3.5 equals the log 47.9. After you move this x value in front, now we only have one more step. Here we go. For this problem, what I'm going to do is I'm going to divide both sides of the equal sign by the log of 3.5. That's what it looks like. Divide by the log of 3.5. And by doing this, these will cancel out to a 1, and what are you left with? You're left with the value of x that you're searching for, and x will be approximately equal, if we round to the 4th decimal place, whatever you get for the log of 47.9 divided by the log of 3.5. Now, x will equal that, but I put approximate because we have to round to the 4th decimal place. And that 4th decimal place was that 3.0885. Well, we're going to do this in the graphing calculator so you know how to type it in. So here you go. Clear all this out. We're going to hit the log button right there. Type in a 47.9. Close the parentheses, by the way. Closing the parentheses. Divided by the log of 3.5. And then all you have to do is press enter. And look what you got. Now, remember, we said round it to the which decimal place? The 4th. There's the 4th decimal place, which is the 10,000s, right? That's tenths, hundredths, thousandths, 10,000. So if that's a 4, that's a 6, that's got to be rounded up to a 5. That's right, it's 3.0885. That's your final answer. Okay? All right, 2 more problems to do. We're going to go down to problem number 14 because it looks a little bit trickier. All right, so we're going to zoom in on problem number 14. Aha! You guys are never going to guess what I'm going to start out doing. Do what? Yeah. Apply the common log to both sides, right? Log 5 to the power of x squared minus 3 equals the log of 72. Now, I'm going to highlight something that's up here in the exponential realm. Does anybody want to guess what we're going to do next? Tatum. Move it up front. Now, when you guys move this up front, when you have an expression, not just one variable, but you have an expression, my suggestion is that you take that expression and put it in parentheses. Because you're taking that whole expression and you're moving it up front. Now, there are more than one way to solve this problem here. I'm going to try to do what I think is the easiest way, okay? And what I would do, if I have two numbers being multiplied together, what I would do is, I'm trying to get x squared by itself. So some people try to distribute, and you could distribute and work through the problem like that. But what I'm going to do is I'm going to do something a little bit different. Because you could distribute and work your way that way. What I'm going to do is I'm going to divide both sides by the log of 5. And these will cancel to a 1. So here's what you have left. You have an x squared minus a 3, which is equal to whatever log of 72 divided by the log of 5 is. If you type this into the calculator, it would be a really, really ridiculous decimal. Okay? Now that we have this, what are we going to do next? We've got to isolate the x squared. So what do I have to do to isolate it? Add 3 to this side and add 3 to this side. By adding 3 to both sides, that zeroes out. And you have x squared now. There's the x squared equals whatever the quotient of this is. Now, what do you guys think the very, very, very final step? Square root. So we're going to take the square root of this. We're going to take the square root of everything. Now, this is where you got to be a little bit careful in the graphing calculator, okay? Because if I have to take the square root of everything, that means I got to make sure everything is where? Inside of the radical. So right now, what I'm going to do is I'm going to hit second x squared. I'm going to hit alpha y equals enter. And in the numerator, I believe it was the log of 72. Is that correct? Denominator, the log of 5. Now, this is where if somebody's going to mess up, this is where they're going to mess up. You have to hit the right arrow and then add a 3. Make sure the 3 has to stay where? Underneath the radical in the graphing calculator. If it doesn't, then you're going to get the wrong answer. Press enter. And so my answer is this. My answer is 1, 2, 3, 4. That's a 9, right? So we have to round it, so it's going to be 2.378 and a 5. And that's your final answer for number 14. Now what I'd like to do, guys, is I'd like to show you how to change. Okay? We're going to go back to our, remember, you guys see that answer right there? We're going to show you how to check. So right now, what number would I need to plug in right there? 3? 3. Is it 7? 8, 5? Go back. Oh, 3.7. That's it. So what you're going to do in the graphing calculator is you can plug it in. So you could say 5 raised to the power, open parentheses. What am I going to plug in? All of this, right? And what am I going to do? I'm going to square it. And after you square it, what do we have to do? We have to take away a 3. And what should that get very close to, if not equal to? See? Should be 72. R says 71.9, not repeating. So why is it repeating? Because even a calculator does what? It approximates, okay, to it as much as it can. One more problem, and that's it. By the way, how we're going to do number 16 is how we're going to do number 15, okay? 16 is slightly harder, so we're going to do 16. Here's your final problem. Madison, could you tell me what you think we're going to do first? That's right. Common law. Bless you.
Bless you. Well,
We feel very blessed at the school. All right. Now, Emily, I highlighted those powers up there for a reason. Why did I highlight the powers? I'm going to move up front. Now, whenever we move something up front and it's an expression, we want to make sure that we move them up front with a set of what? Parentheses. Okay. So with a set of parentheses, here's what it looks like. You're going to have n plus 1 times the log of 2 equals, open parentheses, 2n minus 1 times the log of 5. Why is this problem a little bit trickier than all of the other problems? What do you notice on both sides of the equal sign? What do we have? We have a letter n here, and we have a letter n over here. So we have to kind of move things to where we need to. This is where I would distribute. So right here, we're going to take the log of 2. We're going to distribute it to the number 1. We're going to take the log of 2 and distribute it to the letter n. Here, the log of 5 is going to distribute it to a negative 1 and to that 2n. So how do you multiply a log of 2 times an n? Nope. It's a good idea, though. This number is going to always be up front. So it's n times. Now you don't have to put the dot there, but I want you to understand it's n times the log of 2 plus, what's 1 times the log of 2? It's just log of 2. So if we distribute the log of 2 to both numbers, you're left with n times the log of 2 plus the log of 2. Log of 5 times 2n becomes 2n times the log of 5. And the log of 5 times negative 1 is? Okay, so everybody write that down and let's take a look at this and realize, wait a second, here's our equal sign, right? There's our equal sign. We need to have all the variables on one side of the equal sign and all of the non-variables on the other side, okay? So, you see here we have n log of 2, here we have 2n log of 5. What I'm going to do is take away an n log of 2 from this side, which zeroes that out. Whatever I do to one side, I have to do to the other side. Now, this is where it gets sometimes kind of confusing for students who are just starting with logarithms. I need you guys to understand that these are not the same log. So I'm going to go to a different page so it doesn't get confusing. Watch. If I had a log of 2 plus a log of 2, that would be 2 logs of 2. Does that make sense? If I have a log of 7 plus a log of 7, I have 2 logs of 7. But if I have a log of 5 and I'm trying to say add a log of 2, I can't combine those because those are not the same terms. Okay? Yes, they have the same base. Okay? They have the same base, but technically, this is called the product property. You could say this is actually equal to log 10 of 10 because 5 times 2 is 10. And log 10 of 10 is actually just equal to 1. So log 5 plus log 2 is actually just equal to the number 1. But in order to add logarithms, what do you have to be able to do? You have to have the same terms. So we're going to go back. So that's why you can't just subtract these. You actually have to leave them like this. You have to leave this side as 2n log of 5 minus n log of 2. 2n log of 5 minus n log of 2. I just write it all out like that. Over here, to get rid of this negative log of 5, what I'm going to do is I'm going to add a log of 5. And when you have a negative log of 5 and you add a log of 5, yes, that does zero out. But I'm going to have to do what? I'm going to have to add a what? Log of what? 5 right here. Now this might be a little confusing. But I'm going to write, right now, I'm going to write log 2 plus log of 5. And now, people who have worked with logarithms all their life will automatically know that this is equal to the number 1. For those of you who don't recognize that, we're just going to leave it the way it is. 1. Go back 3. It's 5. That's 2. It's 10. And log 10 of 10 is 1. So that's why when I was doing this problem on my own, when I got this, automatically my brain kicked in, oh, that's just equal to the number 1. Ready? I'll show you. Where's my log? There it is. Log 2 plus log 5. Let's just press enter. Here's the rule. If I have a log, and I have a base, I have that same base, and that's the power of 1, that's 1. That's the rule. So we're going to go and finish this problem now. But we're not going to finish it with that being a 1. We're going to keep using it because not every student's going to recognize that this is a 1. Okay? So, right now, what letter are we solving for? I know we took a little detour right there. What letter are we solving for? N. We have an N right here, and we have an N right there. So this is what you need to do. When you have an N and an N, you got to factor out the N. So here's how you factor it out. You take an N and you factor it out of this expression. So if I factor the N out of that expression, I'm only left with a 2 and a log of a 5. Okay? When I factor it out of this expression, I have a minus a log of 2. When I factor it out, I'm just left with a log of 2. And what is that all equal to? Yes, technically it's equal to a 1, but it's equal to the log of 2 plus the number of 5. Alright, we're down to our final step. The very, very, very last step that you have to do is to divide both sides by this expression. Divide both sides by that expression. What's going to happen to these? They will simply cancel to the number 1. Any number divided by itself is 1. And your value for n will be equal to whatever that is in the graphic calculator. And yes, for those of you who are watching the video, we're going to type this one last thing in to show you the correct answer as a decimal. So, clear this out. I'm going to hit alpha y equals enter. In the numerator, what am I going to type in the numerator? Log of 5 plus the log of 2. And everybody knows that right there is equal to the number 1 now. Alright, in the denominator it was 2 log of what? 2 log 5 minus the log of 2. Okay. We press enter, and we get this answer. We get this answer right here. So rounded to the nearest hundred, not nearest, nearest 10,000, fourth decimal place, 9, 1, 1, 7. I realize most of you are really wanting to dial 911 right now after that problem, but the answer is 0.9117. And let me prove it to you that this is the correct answer. For most of you, you'll stop the video 5 minutes in. But for those of you who actually wanted to see this whole process work, here we go. 2 to the power of what? 0.9117 and 0.9117. So we're going to do this one real quick. 2 to the power of, what was it? Oh, I don't do that. Just going to grab it right there. And what's after it? Was it a minus something? Plus 1. It's equal to this number, right? And then the other one was 5 raised to the power of 2 times the number that we got. Close parentheses, and what do I have to do? I have to take away 1. And when you guys get the exact same answer, or when you plug in what you got for x, remember this is what we got for our variable, right? We got this right here. That lets you know that you got the right answer. Okay? We'll go back. What did we say that was? 0.9117? And they end up matching the exact same number. That lets you know what you got right.